before we start learning what database is, let us first understand how data is managed in usual file systems. So we actually store something, like if you want to store some data onto the disk, right? Say we do have hard disk and any data if you want to store. In that case, like you may store some notepad or ms word file or any mp3 file or mp4 videos, anything. To store anything, you need actually some space on the hard disk. So some space will be reserved for that, and these files get stored onto some location in your hard disk, right? So in the same way, data, so whatever we call as related information, so that data, so that also gets stored on the hard disk in some way. So that, so what we know till now, we can store some data in some files. Say for example, daily we take this some notes into this notepad. Now we have some data in a file called notepad, and this we can use it and we can refer it later in the later point of time if you want to refer. So this data is preserved in a file, and this file is stored on your hard disk file. So we can actually maintain our data in files. So then what's the actual limitation of storing the data in file system? Say for example, we can store the data on any file system, right? Like say for example, MS Word, MS Excel, Notepad, like this. So say for example, I have some university management system where like there are a number of students in that university studying, and where the students data needs to be maintained. So the students data is available to their department wise, so and academic section wise. In the result section, the data of the student will be there, but there that will be different. And in the account section, there will be data of the student. Maybe if there is an hostel, then a hostel office, then uh, the student data will be maintained there. So if you see here, in different departments, so in different sections, we have student data available in the form of files. Fine. Now, let's say for example, if we wanted to find the information of one student, complete information of that student, someone wants to look into it. So just imagine, like we need to first we need to know the location of all these files where we can access the data from, and then after knowing that, we need to open all the files. Say for example, you have some like 1,000 records or 2,000 records. So from that, you need to find out the specific student information in each file. And you might not know like how many files the data is, so you need to open all the files, get the information, and you need to manually search for that particular student information, get the information, and then cumulatively you can put it somewhere, the whole information. See how difficult it is. Say for example, this is fine, and if you wanted to just update the any information of that student, and see, then also you need to open all the files related to that student information, and you need to actually update on all the files wherever the that student information is stored. So this becomes like a tedious job, and it becomes like not that comfortable to actually work with the file systems. Like we can see the limitations. So let's understand the limitations of file system first of all. We have data stored fine across many files, but the issue with that will be, let's see the limitations of it. First of all, there is redundancy. So what do we mean by redundancy is, there will be lots of duplicates. So whatever information you have in one place, maybe in academic section, so you will repeat all the information of that student, maybe student ID, student name, student address, if required, like a student, whatever department he belongs to. This information will be uh, very common, but according to the sections it is scattered, right? Academic section, result section. So each section, let's consider each section has one file. So in each file, this common information of student ID, student name, and student address, contact details, all this might be scattered in each of these sections across all the files. So what are we doing here? So if you observe, the data is duplicate. The data which we know exists in one file, although we know that, but we are actually having them in each file according to our requirement, specific requirement. So that what's happening, same information is stored in many files. So that we call it as redundancy or duplicate data. And this we'll be doing for thousands of students. So imagine how much space it occupies and how much duplicate data we have in the files stored. And also the other problem with this is like if you wanted to update any information for any one student, as discussed, like you need to open all the, first of all you need to find the access, you need to know the location of the file, you need to have the access on the files, then you need to actually open each file and update the information of each student. So even updation is problem here. Next, difficult to data access. So as just now discussed, you need to know the exact location where the files are stored. Should know exact location. And so why we are seeing difficulties? So just now we discussed it. Searching among like say for example, every year students gets passed out, and you also need to maintain the history of the students, right? So for that, let's say for example, if there are like 10K students, so just imagine how tedious job it will be to find one student information among all these 10,000 students. So the access of data is difficult here. And also there can be unauthorized access. Say for example, you have stored information of all the students in one file, and if someone wants to access the data, say for example, if someone wants to actually view their results, say for example, result itself is confidential, then if a student wants to access that file to actually view his result or his marks in a particular semester, then the student will also have the access. Once we open the file, you'll have all the students information at one place. So that student who wants to view his result can also actually view the result of other students as well. So that becomes like unauthorized access to the data. And also not only view, maybe that student can even edit the file, we might not know. So that is one limitation. So unauthorized access, if we have data in a file, we can't actually have it more securely stored somewhere, as we can have unauthorized access. Anyway, a student wants to access definitely to know his information. So in that case, we need to allow student to access the file. At the same time, we should be maintaining the confidentiality. So these two can't be achieved at a time using a file system. And one more limitation is no concurrent access. So what does we mean by concurrent access is, say for example, I opened a file and I am actually viewing the file for some for looking for some information as an admin. Let's say for example, as an admin itself, I am looking, I opened the file and looking for information of a particular student. So you also as an admin wants to actually access the same file, you being in some different location, and you wanted to perform some other operation where you wanted to actually update or adds a new student information into the same file. So that can't be possible. If you observe, like in the files, like only files are like you can't actually write data if someone is open that file for read. So that is what we call it as concurrent access. So at the same time, more than one can't actually work on a file. So if one is open for it for viewing or reading, so other can't open it and write the data into the same file. But if there are like many admins or many students who wants to access the same file, that is not possible. The concurrent access is not possible. So this is another limitation using the file system. So like this, there are like and backup recovery. So you need to how do you actually keep a backup? Say for example, you kept it at some location, and if you have some virus on that machine, or the file is mistakenly it was deleted. So what's the backup for that? How do you recover it? So these are all like limitations when you have data stored in your on your file system. So how to overcome this all these limitations? So the answer is database. So how do we handle all these limitations which are all on file system? So, so the answer is straightforward, database. So if you have a database, first of all, let's understand what database is. Database is just a storage area for data. So you have some data, instead of storing on the file system, we wanted to store it in some database. So as it is storing data, it is called as database. We can call it simply as storage area for data. And if we want to define it, we can define it as a collection of interrelated data. We can say collection of interrelated data is stored in database. And simply we can say it's a storage area for data. And how does like database stores the data here is whatever information we wanted to store. So the information will be divided into pieces like in different categories that we call it as columns. And if we wanted to add some information, that we store it in a row. So database has a table. Database data is stored in the format of tables where we have rows and columns. So a table is a combination of rows and columns, and that is how data is stored in the databases. So for now, just think like that. So we have a database, and in database we have like we can have many tables, and each table. So let me put it here. Each table is a combination of rows and columns. This is how data is stored in the databases. Now let us understand like how we use database as a backend in any application. Let's say for example, we have this is called presentation layer. Wherever we access any application from the browser, that is called presentation layer. And wherever we have the server running, that is called as business logic or business layer, where we have web server running. This is where the application code will be deployed in some web server. It can be any application. And we'll be having a backend database. We can say it as database layer. This is at the backend. So whenever we perform some operation, so this is our application which has web server So server will be running, which is like a black box to us, which will never know that the application is running on some remote host. We are only given this uh, presentation layer. So presentation layer in the sense you have some application which is hosted and running on some web server it is hosted, and you are only given the URL of it to access the application. Using the URL from any browser, we actually access that application and we can use that application. And how does in the backend it works is, so you are here now in the presentation layer, we are here and we can only view the GUI part of it. So GUI, so this is GUI, and we are only able to view the graphical user interface of the application. And when we actually start interacting with the application, what happens is, if you wanted to perform some operation where you wanted to add some customer, so we have business layer here, which is running at the backend. And when we perform some operation from the GUI part or this UI part, say for example, we wanted to do some transaction. Let's say for example, this is some net banking, and you wanted to perform some, uh, you wanted to perform some transaction from your net banking. So what happens? You are only given access to this UI part. From this, you actually perform some. You wanted to do some transaction. Then what happens in the backend is the request will be gone to this, like will be sent to this business logic layer, where actually your request will be processed. If it is authorized request, then according to the logic written here, so there will be a number of programs written by the developers, and this is the actual application here, where the actual business logic lies. So here, according to this business logic, the request which came from the browser or the client, that will be processed, and if it is an authorized request, then that will be sent to the database. Like if you are actually trying to access something from, let's say for example, you logged in into your net banking and you wanted to view your last 10 transactions. So all of your data will not be stored in the business logic. So that will be stored in a database. So whatever data, your data will be stored in the underlying backend database. From that, what happens is, so layer at the business layer, the request will be processed, and if it is an authorized request, then according to that request, so that will be forwarded to the backend database, and backend database responds with some result, and that will be again in the form of database language. So business logic actually converts that into readable format and will be sent back to the UI, user interface, where you are working from, where you access the application from some browser. That's how in the backend the request will be processed. And this is like a two-way, right? Even there can be like one way if you wanted to actually add any beneficiary. So in that case, your request will be passed to the business logic layer, where it will be processed, and that will be actually sent to the database to store it. So here we only wanted to store that information. So in that case, the data will be persisted onto the database. Here we'll have the data stored in this database at the backend. So this is how any application architecture will be. This we call it as a three-tier architecture. And you like when working with these backend databases can be, there are there will be number of databases. So like Oracle, MS SQL Server, IBM DB2, MySQL. This can be any database. Likewise, so this business logic will be developed using some programming languages like Java, Python, .NET, like that. And this presentation layer will be developed using the scripting languages. Scripting languages like HTML, CSS, JavaScript, like that. So this architecture we need to know, because we are going to learn about the database which is at the backend, which is never visible to the client who works at the browser level. So this we are going to discuss, like what we need to understand here is whatever transaction or whatever action we perform from the UI, that will be processed by the business logic layer, and if required the data is stored into the backend database. And in some cases where the request is to actually retrieve the data, then the request will be processed and the same request will be converted into the form which database can understand by the business logic layer, and will be send it to the backend database, and backend database according to the request it responds back with the response. So that response again it will be converted in a form which will be readable by the user who requested from the client or browser, and will be sent back to him to the UI part. That's how the request and response works, and that's how the data is either persisted or stored on the database or read from the database. Now let us go back to this. So we learned how database the backend works. Now we'll discuss what DBMS is. So DBMS is database management system. And DBMS is just a software to manage the actual database. So what DBMS is full form of it is database management system, and that we can call it as it is a software to actually configure and manage the backend database. And database is just a storage area for the data. And as it is only a storage area for data, there has to be some software which has to actually maintain, configure, maintain, and manage the whole data, right? So that software we call it as database management system. Examples of DBMS are DBase, Fox Pro, MS Access, like this. These are the examples of DBMS. And here, like data is stored in the form of tables, fine. And these are the examples of the any DBMS. So at the earlier stages, when like databases were introduced. So we used to have only DBMS, that is database management system, where like using DBMS, the data was managed on the databases. So this is what we call as DBMS, and this is what we used to have in the early days. Then came RDBMS. So what is RDBMS is relational database management system. So why do we need to have RDBMS? We have the software which will manage the database. Then again, why do we have this RDBMS is, say for example, the data can be interrelated. Like say for example, if you have an employee data, so employee might belong to, we have some employee information like employee ID, first name, last name, the department which he belongs to, department name, like that. And the department itself can be a table, or can be a information where we wanted to store it in a separate table in the database. Like there can be like tens of departments where we wanted to store the information of the departments. Like whenever someone wants to view what are all the departments present in some institute or university. So then just actually trying to access one table, we should be able to get the information of that, uh, all the information about the departments. So in that case, what we do is we store the information in, like whatever department information is there, we store it in a separate table in the database. So we understood, like in database, data is stored in tables, and each table has is a combination of rows and table rows and columns, right? So like, and we do store it in many tables. Why do we need many tables? Is this is the reason. So if we wanted to store it in our example, department information, that can be one table. So employee information, that can be one table. So if we wanted to store jobs or locations, different locations, then we can have it as one table like that. And from these tables, we need definitely these tables, if you observe, they have some relation. So employee, we just now learned that employee can have employee ID, first name, last name, department ID, department name, like that. All these information belongs to one employee, right? And the an employee can belong to one or more departments. And we also have department information. So let me put it here somewhere. Say for example, we have some employee information where employee might have employee ID, maybe first name, last name, and employee might have a job designation, salary, department ID, like this. And say for example some department name. Likewise, we wanted to store information which is related to departments. So there can be number of departments, and each department might have one department ID. We'll have department name. Maybe you can just stop here, and then you can see here. If you observe, there is some common information between these two tables, and we wanted to have the relation between these two. Like in the two tables, we might have some common tables where we wanted to retrieve information actually relating to this piece of information in these two tables. So with that, we wanted to actually uh, read the data, or we wanted to perform the operations on the different operations on the databases. So what I wanted to say here is there can be relations between one table to other table where we have some common information. Whenever we have some common information, there can be some relation between one table to other table. And using that relations, we wanted to actually perform operations on the database. That's the reason this RDBMS, so Relational Database Management System, so came into existence just to achieve the relations between the tables. So the examples of RDBMS are, and with this what happens is the data retrieval will be fast, and data can be stored efficiently, and even we can also reduce redundancy as well, using if we have like relations between the different columns which are common across the tables. And the examples of RDBMS are Oracle. Oracle is the first RDBMS which came into the market, and IBM's DB2, Microsoft MS SQL Server, we have Sybase, we have MySQL, which is again like owned by Oracle, like this. We have Teradata, Informix, number of databases, which are all called as RDBMS databases. So relational database management systems. These are the examples of them. Then came, so this is about RDBMS. And after that, there was a requirement for storing like huge data. So nowadays, like everything is about data, right? If you take social media, if you take any big multiplexes, malls, any software, big organizations, industries, everywhere. Uh, they need like they wanted to store data, and that data has grown, and that data nowadays has become such like the requirement of storing the data is huge. So it crossed even like terabytes, and it went like into uh, exabytes, even exabytes, petabytes as well. So for that we need to have some mechanism way to handle this huge data. So then came a field called big data. So what big data is? Big data is a field which came into existence to handle huge volumes of data. Data has become like data is coming nowadays in a huge volumes. Like you can take any social media websites like that. So there will be lots of volumes of data generated each day, right? So how to handle that much like huge volumes of data? So to handle all these like volumes of data, huge volumes of data, there came a concept called big data. So big data is just a field. We can call it as a field to handle huge volumes of data. And like examples of big data is Hadoop, Apache Spark, Apache Storm. We even have BigQuery by Google. We call it as Google's BigQuery. All these are the technologies which actually work on the big data. Big, and remember, big data is handling of huge volumes of data. These are the different technologies which implements big data. We'll discuss what SQL is now. So let me go back. Now we said like we have some database here. Say for example, this is database server, and you wanted to communicate with this database. So why do you wanted to communicate with the database? As we wanted to perform like maybe we wanted to insert some data into the database, or later point of time whatever we inserted, we wanted to update some information, whichever we inserted. And if we don't need that data anymore to be stored in the database, we wanted to delete that data. Let me put it here. We can insert data. We wanted to, if you want to update the data which is already present in the database, we wanted to update data. And if we no longer need some data on the database, we wanted to delete the data from the database. And even if you wanted to, there is some data in it, and we just wanted to read some data from the database. So that we can call it as reading data, or we can say retrieval of data. All these operations we wanted to perform on the database. So we have data stored in the database, and we wanted to perform different operations on the database. But how do we perform all these operations? So database will have like how do we talk to the database? So we wanted to actually perform some operations on the database, and which is why we wanted to perform the operations on the database. So the data is stored on the database. uh, that's the reason we wanted to actually communicate with the database. And like how to communicate with the database is, so database has its own language to communicate, that is called as SQL. So it is called as structured query language. Using this structured query language, we can communicate with the database. So in order to work with any database, so we need to know SQL. This is the language which database can understand. This is called as SQL, structured query language. And these are all the different commands. Whatever we are seeing, like insertion, update, delete. For performing each operation, we have a different SQL command which will issue onto the database, and database responds to that command accordingly. And these commands are called as SQL commands. And the language which we communicate with the database is called as SQL, so structured query language. And in that language, we have different commands to communicate with the database. Those commands we call it as SQL commands. And SQL is, as discussed earlier, SQL is common. So once we learn this SQL, that is structured query language, which a database can understand, if you can learn this SQL once, then irrespective of your database, either it can be Oracle, MS SQL Server, Sybase, any database. So the syntax remains same. So what do I mean by syntax is, whatever SQL command you issue to communicate with the database, so the commands or the SQL syntax will almost match from one database to another database. It's like you can say 85 to 90% it will match. So that's the advantage of learning SQL. So once you know SQL, it can be any database. So you just need to know the uh, differences between the one database and another database will be small syntax differences in the SQL commands. But everything, whatever command you write, the logic or the command you write to retrieve the data from the database, so that remains the same across any database. So let me put it here. What is SQL? It's a language used to communicate with the database. So we should be saying database server. Now let us understand different database components. So we have different database components, like we have client and server. We'll learn what client is, what server is. Now the data, we learned that we have data and it is stored in the database. We call it as database server. So now we have data stored on the database server. So how to access? We know that we need to definitely learn the SQL. SQL is structured query language, which database can understand. So in order to communicate with the database, you definitely need to communicate with in that language, SQL language. So we need to learn that SQL. Fine. Let's say, for example, we know the SQL language now, but from where do you issue these commands to the database server? So that is important, right? So from where do we issue is, we have something called clients. We call it as client. So database is called as database server, and we also have a client. So we call it as database clients. So where the data is stored is called as it is database server, and from where you access it is called as a database client. And what do we do here? From the client, we wanted to actually perform the operations onto the database. So different operations are like, so you actually request for some data to read, then database responds with the whatever data you asked for, or you wanted to persist some data, so it will be one way. you just send some request to persist your some data. Database just stores the data onto the database server. So client is one way where you actually start issuing the commands to the database server. This we call it as the database client. And how do this from this client? How do we communicate with the server? Using SQL again. Using SQL commands. As SQL is the language used to communicate with the database server, we issue SQL command from database client to the database server, and that's how we communicate with the database server from any client. So we need a client to communicate to the database server. So this is the place where we actually start connecting to the database, and then we'll start issuing the SQL commands. And remember, this client can be anywhere, and this database server also can be installed anywhere. And mostly this database servers will not be installed on your local systems. So this will be installed on some remote machines, which are usually like Unix or Linux systems. As a installing, configuring, and maintaining these databases, so we need like a huge hardware configuration. So for that reason, we will not have these database servers installed on our local machines. These database servers are on some remote machines, that too on operating systems like Unix and Linux systems. And these DB clients are lightweight, so they are not like you don't need like a huge configuration for installing any database client. So it's a lightweight one. Client is a lightweight one where we can install even on our local machines as well. And we just need some parameters of where the database server is hosted, like the host name where database is running. And we have a concept like port. So we also need each database will be running on some port. Port is usually like 4 will be represented with a 4 or 5 digit number. So you just need that port number and the host and some information like for any application to log in, you need to prove yourself your authentication, right? So in the same way, onto the database also you need to prove your authentication. So you need your credentials to access the database. So these are the parameters you need to know. Host name where database is running, a, a port number where the database is running, these two, and along with that, the credentials to access the database server. So if you have these parameters, you can actually install your database client, which is lightweight. So you can install directly this client on your local machine, and you can start connecting to the database, and you can actually work with your SQL commands to communicate with the database server. Most of the time it will be like this client, say for example, the database server is on the remote server, and usually what happens is people who are at the remote location, say for example, in an organization, if you wanted to work with some application which is hosted onto some web server, and the backend database is in some remote server, and say for example you wanted to directly access the database server. So in that case, you as a client, let's say for example all these are clients. So one or more number of clients can actually connect to the database at the same time. So each one gets their own connection. Like say for example, uh, this client, this guy wants to connect to the database, so he gets his own connection. Likewise, so anyone who is connecting to the database is called a client. And how do they connect? They connect to the database once they install the database client on their machines. And the second step is they need to know the parameters. So just now we discussed parameters. So what are the parameters? Let me put it here. Where the database host is running, on which port it is running, and the credentials to access the database. If you have these parameters, then you can connect to the database directly. and access the data. So all these are called as clients. So there can be one or more clients for one database server, but the database server will be one, and there can be one or more clients for the same database server. So there can be multiple clients connecting to the database server even at the same time. Each one will be having its own connection. Each client will have its own connection, and all these will be maintained by the database server. And usually in any organization also, someone wants to work with the database, so they only install database client on their machine, and this database server will be installed in some remote server and will be provided these parameters of the database, so that as a client from your machine, after installing your database client, so you'll start like with these parameters, you'll start connecting to the database and you'll start communicating with the database server. And about this client, there are like two types again, two types of clients. Let me put it here. We learned about the database components, what client is, what server is. So server, where data is stored, client, from where you uh, actually issue the SQL commands to communicate with the database server. That's the definition. And we have two types of clients. GUI client and CLI. What GUI is? Graphical user interface. It's called graphical user interface. Where you'll have an application with the user interface, rich UI. From where it is also called a client. From where we'll connect to the database and we'll actually start performing operations on the database server. And one more client is called as CLI. So that is command line interface. Where we'll not have like a graphical user interface. It will just be like command prompt. So you will just issue some commands from the command line interface and will start working with the database server. We'll start performing the operations on the database server. So these are the two different ones. And for any database server, so along when you actually install database server, we'll have an option like if you wanted to install both server and client or only server. So these are the three options you'll be getting. So database, you wanted to install both database and server, or only server, or only client will be the options you'll get. And with that options, we need to carefully select the option which we wanted to install. So everything is a software, right? So we need to carefully select the option which we wanted to install. And as discussed, database server will be installed only once, that too on a remote server. And that server will be running on a remote server where different clients will be connecting to the server. And in order to have a client, you will actually start installing the same software, but at the stage where where you get an option to select between server, client, both server and client, you will select only client, so that as a client is lightweight software, so it will be installed on your machine. So and then you can start working on the database server. And types of clients can be graphical user interface and CLI. So any database has it like this. And say for example, you install Oracle. And what are the graphical user GUI clients you get with Oracle is, let me put it here. You will get SQL Developer and command line interface. You will get it as SQL Plus. SQL Plus is the CLI. You will get it with the Oracle. These are the default clients. Also, we can actually work with a number of other clients as well. These are the clients which come with the database server. We also have some third-party clients like Toad. You can actually install Toad and also connect to the Oracle database. And also we have something called DB Viewer. We have like Aqua Data Studio, DB Visualizer. Like this, there are many clients. These are the examples of GUI clients which we can install on our machine, which are lightweight, and we can if you have parameters of the database server, we can start connecting to the database. Likewise, we have CLI as well. Like CLI in the sense, like whenever we install the database server, we'll get some default command line interface as well. From where we can actually issue the commands. So here you'll not have some that graphical user interface. You just need to, it will just look like your command prompt where we will issue commands. So that is what we call it as CLI. And these are the clients for Oracle, right? So in the same way, when we install MySQL, we get Workbench. We call it as MySQL Workbench. We also get command line with this. And like any other client, so you can use Toad to connect to MySQL, and you can also use DB Viewer. These are the different clients available, database clients available, which you can install on your machine, and you can actually start connecting to the Oracle database or MySQL database, any other database. These are the examples of the clients. And these are of two different types. One is GUI, graphical user interface client, and another is CLI, command line interface. We are going to install MySQL now. So why did we choose MySQL is, MySQL database is like, it's a lightweight database. So till now what we discussed, in order to install database server, it has to be mostly installed on a remote server. So all other databases are like you need a good configuration to install the databases. So once if you actually install other databases like Oracle MS SQL Server, you need like good configuration on your machine. Otherwise, like the memory will be used up by that database server, and your machine will become slow. You can't actually use it for any other purpose. That's the reason we usually put the database servers on some remote machines. But MySQL is an exception to that. MySQL is a very lightweight database where you can actually install both your server and client also on the same machine. That's the reason we choose MySQL to install. Like that's the reason we actually decided to learn MySQL so that we can install both database server and client on our machine, local machine, and we can start learning the concepts of the SQL. Now let's actually see how to install MySQL. I already have MySQL database server and client both installed on my machine. So I can't actually show you the installation on my machine, but I have a step-by-step clear documentation of it, how to do it. So we'll go through that now. So the first step which we need to do for installing MySQL is we need to visit to this URL. So you just need to visit this URL. Once you click on this URL, you will see a image like this. You will see a web page like this, MySQL installer for Windows. You can just click on this, go to download page. Then you will see another screen like this, where you can find, this one. So the version of MySQL installer, and then Windows x86 32-bit MSA installer. You can see it here. So then you can actually click on this. So don't click on this small size one. So it is only 20 MB size. So even though you click it, you'll not get the complete software. Again, it will start downloading. So instead of that, directly download this MSI installer, where you will get the complete installer. So once you click on this, you'll get an option like this. So click on this download now. It will be around 370 MB. So just click on this. Then you will be navigated to the, as this is MySQL is also owned by Oracle. So you'll be asked to enter the Oracle credentials. So don't worry, even if you don't have an account, just go ahead and click on create account, so that it will just ask you some basic details. Provide your basic details there. Then that's how you can create the account. And then you can log in to the Oracle website just to download this MySQL software. And once you download it, you'll get installer .msc file on your machine like this, which are highlighted here. Once you get this, just right click on that and just say run as administrator. Then you will get a screen which you see on the left side on this page. So you can see license agreement. Just check on this. I accept the license terms and click on this next button. Next, you are asked to choose this setup types. So by default, it will be developer default. So just select this developer default and click on next. Then it will check for the requirements. So in order to check the requirements, like these are like prerequisites before the database is installed. So you can just click on next. So it will throw some warning here. One or more product requirements have not been satisfied. You can just ignore it. It will ask you still you want to continue. You can just click on yes here. And then you will get a wizard like this. So whatever you are seeing on the left hand side in the screen. So installation. So you can see installation of all these products will be installed is what it is saying. Just go ahead with clicking on execute button. So it will also, then you will get a screen which looks similar like whatever you are seeing on the right hand side on the screen now. So just click on next. So all these products will be installed is what it is saying. So fine. So just click on this next button again. This is talks about product configuration. So here also you can just read this and just click on this next. Then you'll be getting some option like high availability. So by default, it will be selected on the standalone MySQL server. So click on, even if it is not selected, just click this and select this, and then just click on the next button again. Here you can see the port number. So just now we discussed any database server, it will run on some port number. By default, MySQL server runs on 3306. So if that port number is available on your machine, it will automatically provide that port number. So you can see it here. Likewise, like if you are installing Oracle, you will have the default port as 1521. If you are working with my MS SQL server, the default port is 1433. Like that, each database will have some default port on which the database server will be running. So you can see here 3306. It's a TCP IP. It uses TCP IP protocol. So you can just put it as is everything, and you don't need to change anything here. Just put it default values here. Just click on this next button. Then it asks the authentication method. Use strong password encryption for authentication. So just go ahead and click on the next button here. Then so observe here now. It will ask the MySQL root password, accounts and roles. You'll see something called accounts and roles screen, MySQL root password. So you can provide any password here, but just make sure you remember whatever you provided here. So for that, what you can do is you can just provide root here and repeat the password, same password here, so that it's easy to remember. As later point of time, we wanted to, if we wanted to log into the database, right? So we wanted to provide the credentials to access the database. So at that time, we need to provide these credentials. That's why be careful, provide some password here, but just make sure you remember whatever password you provided here. And here you can just click on, this is MySQL user accounts, where you can actually uh, click on this add user, and by default you will have this username as admin. So put it everything as is, and you can just say MySQL credentials here. You can pass it as admin and admin. Provide passwords as here also you can provide any passwords, but just provide it as it's easy to remember, right? So if you want, you can just provide it as admin and admin. Even though it says password strength as weak, you can just ignore and click on OK. So likewise, you can create any number of users here. You can see here. So you can just click on add user again and create another user here. So for now, you can just create one user account, admin user account, and just click on this next here. You'll be clicking on OK. This username, whichever we are adding here, will be displayed here as that user is added. And then you can just click on this next button. So if you see here, once we add this admin user and click OK, you'll be getting a screen like this as the user is added here. Then just click on this next button. Then you will see a screen like this where it will ask whether to configure MySQL server as a Windows service. So we do have Windows services. If you observe, click on your Windows key, and if you type services, so you'll get services here. So these are the different services running on your machine. So it is asking here whether you wanted to configure MySQL server as a Windows server. Just click on that if it is not selected by default. So we wanted MySQL server to be running as a Windows server. So just make sure that this checkbox is selected, and we can provide the Windows service name. So we have all these are services running on our machine. These are the services running on my machine, and each service has its own name, right? So that is what it is saying. Provide some name, Windows service name. So you can provide some name here, or else you can just leave it as is default one. Default one is MySQL some 80, mentioning the version of it. And also you can check this, start the MySQL server at system startup. So it will start the MySQL server once it is installed, or like at system startup. So whenever you reboot the machine also, by default that this MySQL server service will be started. You don't need to do it manually. And then just click on this next button. And you can see these are all like applying the configuration. You can just click on execute here, and after a few seconds, like it might take some time at this step of initializing the database. As you can also see here, it's saying may take a long time, so it will take a few minutes. So just you can click on wait for it until it is completed. So once it is done, you'll get a screen like this. Once it is done, you'll see all the check marks here, all the tick marks here for all the things mentioned here. For all the steps mentioned here, you'll see some tick mark here in green, which means that the configuration is successful. Then you can just click on the finish. Then you'll see so you'll see another product configuration here. Just click on this next again. Now you'll see that port number, management user is root. So if you wanted, you can click on this test connection and check, or else if it is disabled, just click on this finish. And again, you'll get this screen again. You'll just click on this next. Mostly it will be like if you are not sure what to do, so you can just accept the default and just go ahead by clicking on the next. So you can see here, server has been installed successfully, and you can see the status of it. MySQL server 8016 version is running on port 3306, Architecture of it is like 64-bit. It is standalone server, and the status of it is running. You can provide the username and password here and click on check. So just now we provided the root password, right? Whatever password you gave there, so just provide that root password here and click on check. So it will tell you whether you are able to connect to the database successfully or not. So here itself you can make sure like you are able to connect to the server successfully. Then just click on next. So you can see here, this is how it will show you. Once you click on check, you will get a message like this: connection succeeded in green, and you can see all connections succeeded. Just click on next. This is just to confirm server is installed and whether you are able to connect to the server successfully or not. And you will get some configuration steps here. If there are any features installed that need configure, you can just say execute here. And once it is done, you'll get an option like a button like finish. Just click on finish. So again, you'll click on next. Then as a last step, so it will say installation complete. And if you wanted to start the MySQL Workbench after setup is what it is saying. So what is MySQL Workbench? It's a GUI client for accessing the MySQL database server. And MySQL shell is command line interface. So each has its own name. So GUI client for MySQL is called as MySQL Workbench, and MySQL shell is CLI client, command line interface. Just click on finish. And with that, we are done with like installing MySQL server on our machine. And we'll also, along with that, we'll also get MySQL Workbench as well, GUI client as well as the CLI client, as you can see it here. So this is how your CLI client looks like on the top, and on the right side you can see the GUI client. We'll see that now, but these are the screenshots like how the workbench looks like and CLI client will look like. Once you are done with the installation, you can actually access these two clients. So this is how I'll be sharing this document with you. You can just follow this document and just install MySQL database server on your machine. So as the whole process would take around 20 to 25 minutes. So I just had these screenshots. So you can just follow this document to install MySQL database server on your machine. Now we'll see we are done with the installation. Installing MySQL server is done. Now we'll see MySQL Workbench and MySQL command line. Once you have installation of MySQL on your machine, so you just need to press your Windows key on your machine if you are using Windows, and then type MySQL Workbench. So you can see as soon as I type MySQL, I get two options: MySQL Workbench, MySQL command line client. So let's start with Workbench first. So I'll just click on MySQL Workbench. So 1 second. Just type MySQL and you'll find Workbench here. Just click on the Workbench. This is the client we are going to use to connect to the MySQL database server. And you can see there are already some connections created here. So when you create a connection to the database server, it actually gets stored on this front page, which we can call it as like some welcome screen or dashboard page. And if you want, like for the first time when we are here, you will not find this. You will only find this first one. You can see the information here. It is saying it is the local instance with the name MySQL 80, the Windows service name it is saying, and it says that the username is root, and these are all the connection parameters to the database server. You can see localhost colon 3306, meaning database server is running on a host, local host. So The current machine, like whatever you are working, is called as localhost, which is also represented using the IP 127.0.0.1. So just remember this. We call our host, our own machine as localhost, or we can represent it with the IP address 127.0.0.1 as well. Colon port number on which the server is running. This is what we need to provide to connect to the database server. This is the first thing we need. And to connect to any database, like say for example, you wanted to create another connection to any other database. So how to do that? Let's see that. You just need to click on this options. You can see some options here on the menu bar: file, edit, view, database, and all. So let's say for example, we don't even have this. So we wanted to connect to a database. Just click on this database. Click on this connect to database. Now you will get some options here. If you wanted to connect to the already stored connections, is what it is saying. As I already have two connections, so it is showing me these two connections. In your case, it will show empty, and you just need to provide some name here, and then you will be providing the host name. This is what I have been mentioning. So the host name is where the database server is actually running. As it is running on my local host in the sense on my machine itself, I installed database server as well. So I am providing it as local host. It has to be exactly the same. So it is not case sensitive. So you can just, but you can just provide everything in the small case. It is local host. And then you can provide the port number. This is the port number which we got by default while installing the database server. So if you had given some custom port while installing, you will be providing that port here. And then username is root. So we need host name, a port number, then credentials to access to connect to the database. So these are the credentials. Root is my username and password is, so it's stored in vault. So you can just click on store in vault and provide your password. I give my password as root. So I am providing root as my password and click on OK. And then just click on this OK again. So this is how you will get the connection. So you can see it here with this name MySQL at the rate localhost whatever host name dot port number. With that it got a connection got created, and you can see we have some space here, huge space here, white space. So we'll discuss everything now. This is what the GUI client is, and you can see something called administrator here. In your case, as when you log into for the first time to the workbench, you will be seeing this administration. So you can see it here. These are all like related to the administration. So the startup and shutdown of the instance, the server status, what are all the client connections running on the server, what are the users and privileges. All these are data export, data import, all these are all related to the administrator activities. So if you want, you can go through this also. But the main thing which we'll be working on is the other tab, schemas. So just click on this schemas. And whatever you are seeing here are called as schemas. So what is a schema is? A schema is a collection of tables. So we have a database. So let me explain you that first. What is database and schema? Database is just a storage of data. Where we store data, it is called as a database. It is just a storage area. And what is schema is, under one database, you can have one or more schemas, and each schema is a collection of tables. So as we know, data is stored in database in table formats, and we can have n number of tables. So grouping up of these tables is one schema. Like if you wanted to group some tables, whichever you wanted to call it as one group, that group is called as one schema. So you can see it here. So by default, you will get SYS schema along with the database server installation. And these are all other databases which you are seeing are the schemas which I created. So by default, you will get one schema. So SYS schema, sys schema, all the other schemas which I created them in my instance. So schema, here we need to understand schema is a collection of tables, grouping of or grouping up of tables. Say for example, I have some demo DB. You can see it here. If I click on the tables under this schema, there are some tables. These two tables, I wanted to group it and have it one name to it. You can just understand it like this is one folder and inside it you have some files in it. So you have one folder and maybe you have some text files inside it. So folder is just for organizing the files, right? Different files. Like that, you can understand. Schema is also just to organize or to group the tables. That we call it as a schema. So and we can have n number of schemas in one database. So this is all one database, MySQL database, and in it we have number of schemas. We can create number of schemas, and under each schema we can create tables. Say for example, you can see it here. This is another schema where I have number of tables here. So all these tables I wanted to group and wanted to have one name to all this group of tables. So I named that group as classic models, which we call it as one schema. This is the understanding of database and schema. Database is a storage area of data and we'll have one database for one instance. Schema is a group of tables. Just for organizing. This is what a schema is. Let's go back to the client again. This is called MySQL Workbench client. This is GUI client that we understood. And what we understood, we can have schemas here in under one database. You will get sys schema. By default, you'll get sys schema. And all the other schemas we need to create. And under each schema, we can create one or more tables under each schema. This we learn. Now, what we'll do is we'll go back to this. So we'll start. We learn MySQL Workbench, MySQL command line client, right? Okay. So, and we saw here the schemas in the UI, right? So in the same way, we will also see how to access the client, CLI, command line interface client. Till now, whatever we saw here, we will mostly work on this. So in the coming sessions also, we'll be working on this GUI client, but I'll also show you how to use command line interface. So again, just click, press your Windows key and again type MySQL. So under MySQL 8.0, you'll see command line client. Just click on it. So it will ask for password. So just enter your password and then you are connected to your database from your command line client. As this is command line client, we always need to issue some commands here to actually communicate with the database server. Say for example, I wanted to see all the schemas. So for that, the command is show schemas and semicolon. So each statement should be actually ended with a semicolon. Each SQL command should be ended with a semicolon. Show schema semicolon is what I issued to the database. And this is what the response we got from the database server. You can clearly see it here. The data, so it says database and it actually issues some schema names. So why it is saying database here is Usually database is the storage area of the data and schema is the grouping of tables is what we learned, right? But here in MySQL, so the terminology is database. Schema can also be called as database. It's just a coincidence. You should not be getting confused with that. So schema is it is like grouping of tables, and schema is also called database in uh, MySQL. So just remember that. So whenever we say database or schema, both are same in MySQL. That's the reason, even though I say show schemas, it is actually listing us under database, all these schemas. So you can also say databases. See, even if I say show schemas, I get some result of like it actually gave us some schema names here. Some of them we might not see. Those are all like internal to MySQL database. So those are coming from the server. And you can see if I issue show databases command also, I am getting the same response here. So meaning like whenever we say database or schema, it is same in MySQL. Just remember that. And say for example, if we wanted to use some schema, the first command we need to use is use demo db. Say for example, I wanted to work with one schema. I wanted to actually retrieve some data, or I wanted to see what are all the tables present in one schema called demo db. So the first command we need to use is we need to tell MySQL database server that I am going to issue some command on a schema called demo db. To say that, we need to use command called use demo db semicolon. So it says database changed. By default, it will be pointing to default database sys in MySQL. But we wanted MySQL to change the context to the demo db schema. So for that, we use the command use demo db. Now we are into the schema called demo db. Here we wanted to issue another command called show tables. I wanted to see what are all the tables present in my demo db schema. So for that, we will issue a command called show tables semicolon. So it will database server actually responded with the result saying that you have this is the list of tables in your demo db is what it is saying, and this is the list. We can clearly see there are two tables, employee and locations. It will also say how many records or rows has been written here, two rows, and how much time it took to actually get the data from the database server is also displayed here. Like this, we'll go on. We need to know some SQL commands to work with this command line client. So we will issue some command. If that command is valid and is valid with the correct syntax, then database server understands that command and returns you the data which you requested for. And like this, you go on you will be issuing the commands from the command line client as well to work with the database server. So if you observe, the first one was MySQL Workbench, which is the GUI client, and the second one is the CLI client, command line client, where you can actually issue the commands. Now let me minimize this. We'll come back to this GUI client, where we wanted to perform some database operations. Say for example, we'll go to this demo DB, and I wanted to click on this. So we learned that these are the different tables under the demo DB schema. I have two tables here. You can clearly see I have two tables, employee and locations. Say for example, I wanted to view data from this employee. Then how do we do that from the GUI client? You just need to right click on this table and then select on this select rows, limit 1000. And then you can see some windows here at that down. So some command got executed here, some statement got displayed here. So we'll come to that later. But if you observe in the down, so we have two windows. So first one is result, called as result grid, and you can see data here. So there are three columns and two rows here. So what is called a column is this is the information of the employees, and you can see EID is one column, E name is one column, designation is another column. All these are like a piece of information of an employee. It is divided, segregated information. You can see it here. Each piece of information is called as one column, and that we read it from left to right. You can see it here. EID, E name, designation. And now we'll read it from top to bottom. So you can see the entire information. 101, employee ID, employee name is Smith, designation is manager. So if you read this whole thing, this is one information of employee. So this is information of one employee. If you observe, all this thing is called as one row. So the information which is like scattered into different columns, if we actually get it for one line, one horizontal line here, that we call it as one row, which is the information of one employee. Likewise, if we come down, we have another employee information. You can see it here, 102 Alan clerk. All this information is called as another row. This is how the rows are stored. Like like this, you can have number of rows. So this we call it as rows. So rows we read it from top to bottom. Let me put it here. And columns we read it from. So these are the, when you are reading it from left to right, these are called as columns. Column is a piece of information. And rows we read it from top to bottom. These are called as rows. So you can see from top to bottom, like I wanted to start it from top, and what's the first line here from the top. So you can see here 101 Smith and manager is the first row. This information is one row, and next row is this one, the total information. This is called another row. Like this, we can have n number of rows here. Also, we can have these pieces of information, like many pieces of information of this employee, of like each one is called as one column, that we read it from left to right. This is a, and the total thing we call it as one table. So this is how data is stored in the databases, rows and columns. And you can see another window here down. So action output. So it actually tells you some information about this action. Whatever action we perform just now, it is saying about that action. So it says rows written. So you can see we have two rows here, and it returned these two rows. And what's the time taken to fetch these two rows from the database server is also mentioned here. With this, actually, if even if there is some error, which are like even if there is some error occurred while execution, we can see that in this action output window. And usually you'll also have this SQL additions snippet box. So if you to hide this, you just need to click on this window, rightmost window, small window. Just click on this so that it will be hidden. And if you don't wanted to see this output, action output window, you can just click on the second one. So you have three squares here, right? So the second one, if you click on it, even that will be hidden. And the most important one is editor. This is whatever we are seeing here, this whole space, this white space, this is called as editor. At beginning, you will not be seeing this. You will be having like this. And how to open an editor? for writing the SQL commands is you just need to go to your file and then click on this new query tab. So click on this new query tab. This is how you will get an editor. This we call it as an SQL editor, where we actually write the commands. So SQL command is called a query. So from now onwards, we are going to call it as a query. Structured query language, right? So whatever we write a command which database server can understand, that we call it as a query. From now onwards, whatever we write it, we'll be calling it as query. Just remember that. And you can also open this editor from here also, from this icon bar. You just need to click on this first icon, SQL plus, right? So you just click on this, you'll get an editor like this. And here we'll start writing the queries. And for now, so just we don't know like how to write the queries. For now, what we can do is we can take the help of this GUI client and just right click on this. Just now we saw this. So you just go to the tables. So for example, locations. So just click on locations and you can select rows. It will give you the data, whatever is present in the locations table. You can see it here. This is the data in the result grid. So we'll see how to actually write the queries, how to create the schema. We'll start it like from creating the schema. So you can see schema and database is same is what we learned right just now. So we'll actually create the database. We'll actually create one table. We'll see how to add data, that we call it as inserting data into the table, how to read the table. All these topics we'll go through one by one in the coming sessions. So in this session, what we learned is like we started with what's the need of having a database. For that, we understood what are the limitations of the file system. Then we understood what a database is and what is DBMS and RDBMS is. What are all the different types of examples for that? What big data is, and why do we need to learn SQL? So SQL is a language used to communicate with the database server. That's the reason we definitely need to learn the SQL. And we also saw what are all the different database components we have. And like we saw like there are two types of clients for any database server, GUI client and CLI client. And we saw like how to install the MySQL. So we have seen the screenshot like how to install the MySQL database server. And why did we choose MySQL as the database? So it is a lightweight database, as we can also install on our local machines as well. So we install that on our so we have chosen MySQL as the database server. Then along with when we install MySQL, we'll database server, we'll also get the two clients, GUI client, which we call it as MySQL Workbench, and command line CLI client, which we call it as command line client. Then we understood what's the difference between database and schema, and we have just seen like how MySQL Workbench GUI looks like, and how we can actually connect to the MySQL server from the CLI command line interface. So in the next session, we'll discuss about the next topics. That's all for this session.